Hey there, I'm Logan Kemper, and in this video I'm going to lead you through setting up a top-down player controller in Unity. In the previous video we covered setting up a platformer slash side-scrolling player. This time we're going to go over top-down multi-directional character control. So think Zelda instead of Mario. This is what you'll want for a game that's closer to old-school Pokemon, Undertale, Vampire Survivors, etc. Make sure you've watched the previous video first, because this video will assume that you've already experimented with game objects, components, and the animator before. Alright, so continuing where we left off with this side-scrolling player controller, let's just save this scene in case we want to reference it later. So I'm going to go File, Save As, navigate to my Scenes folder, and we'll just call it Player Side Scroller. Okay, we're going to create a new scene for our top-down player controller. Though you could continue with the previous one if you wanted to. Okay, new scene, basic 2D built in, create. All right, so we're starting fresh. First, what we're gonna do is set up our player capsule as we did before. So I can right click in the hierarchy, 2D object, sprites, capsule. We'll call this top-down player. Over here, we will add our rigid body 2D like we did before. And we also need our collider. So last time I used a capsule collider 2D. You could also use other types of colliders depending on what kind of shape your player is going for. So in this case, we could actually use a circle collider because the player that we're going to use is fairly circular. If you go under the component window, go to Physics 2D, you can see all of the different colliders. Generally, circle or capsule are the two I suggest. If you use a box collider, you'll often kind of get stuck on edges a lot, so I don't recommend that unless you want to do a lot of troubleshooting. So I think capsule is your best option, but in this case, let's just use circle just to show how it might be a little different. So if we zoom in the scene here, you can see it forms this circle around the capsule, and just like before, we can change its radius, its offset, and some other settings. But let's go ahead and add our top-down player controller component. So we can find that under scripts. I'm gonna go to list view, player movement top-down. Just gonna drag that on, and I will put that at the top of the list of components on this game object, as we did before, just for convenience. We have fewer settings on this one, as a top-down player is going to be a little bit more complicated animation-wise, but a little bit simpler in terms of like platforming, movement, navigation of the level. So we can skip over animator for the moment, just go down to our movement settings. So we have our movement speed, which is exactly what it sounds like. We also have our movement mode, so in case you wanted to limit your player to just moving in 4 directions or vertical only, but we want to keep our player multi-directional. All right, so we have that facing transform similar to before. So this is really easy to set up. We can just right click on our player, create empty, call it facing transform. And then because in our player's default state, they'll be looking down sort of. I'm just going to move this transform down a little bit. I'm gonna hold control while I do it. So it just moves it down 1 unit. So it's just -1 on the Y. We can drag that in. And like before, we're not going to use this yet, but later on that's going to be useful. So the next thing we can do is just play our game and make sure we can in fact move around. So game is running and we see our player very slowly falling. And the reason for that is because our rigid body has gravity on it. So we're just falling to the ground. As you can imagine, we don't want gravity pulling our top-down player when the perspective is supposed to be top-down. Up is more like north than it is like actually up. So we can just zero out our gravity scale here. And while we're here, we can do the same settings we did last time. So set collision detection to continuous, sleeping mode to never sleep, and interpolate to interpolate to make sure our player is smooth and responsive. We're also going to want to freeze our rotation again, and to show why, I can create a little obstacle for our player to bump into. So 2D object, sprites, square. I'm going to drag that out since it just put it straight onto our player capsule. Okay, this square I'm going to add a box collider 2D so that it has physics. Then we'll play. And we can in fact move around, and bumping into this box makes us spin. So that's exactly why we want to freeze that transform. Unless you want your player to be a Beyblade, in which case maybe that's desirable. So anyway, under constraints, we can do freeze rotation. We should be good there. All right, let's play again. And our player is moving around just fine. The collider does not quite line up with the bean shape we have, but it's okay. We will replace that shortly. You can also see this facing transform that we assigned. If we click on it and then look at it in the scene view, as we move around, we can see that facing transform sort of move out in the direction that the player is facing. We can also, if we go to this global setting here, set that to local, we can see that this facing transform actually points on the x-axis, the red one. It will actually point away from our player to confirm that it is indeed facing the right direction. And it'll even face at like a 45-degree angle. And that's because of our movement mode set to 8 directions as opposed to 4, where I wouldn't be able to move diagonally. But those decisions are up to you as the game designer. All right, let's make this thing look like an actual player. Like before, I'm going to be using the sprite sheet that I have in the script package. So this one is a really clean, easy to use one of this little like princess character. If I go image, canvas size, we can see 64 by 112. So if we zoom in a little bit on one of these, I'm going to grab my marquee tool and then select, we can see that it takes up exactly 16 by 16 pixels, which will make this extremely easy to slice and set up for our animations. All right, I'm going to drag that sprite sheet into our sprites folder, then click on it. If you name a folder sprites exactly, then when you import an image into it, it'll actually automatically set the texture type to sprite, which is just a little convenience. So anyway, we don't have to change that. We can leave that as sprite. We'll keep that as multiple because there are a lot of individual frames on here. For pixels per unit, I can already say that this is going to be 16 because our character is, as you saw, on that 16 by 16 frame size. Continuing down, we should set our filter mode to point, because as a reminder, we do not want filtering on pixel art, but on higher resolution graphics, then we may indeed want filtering. And then disable compression entirely. Press apply. And now back to the sprite editor to chop this thing up. So this one's going to be super easy to chop because of how nicely it's been created. I can click slice, grid by cell size, type in 16 by 16, and look at that, perfectly chopped up, no need for any editing. So we'll click slice and apply, exit out of that, and now we can see that our princess has been cut into many pieces. Like before, I'm just going to grab one sort of default pose for this. Let's see, yeah, it can just be that first one of her facing down. So I'll just drag that into, nope, I'm sorry. I need to create the sprite renderer first. So I'm going to right click on the player, 2D object, sprites, and it doesn't matter. We can just set it as a square for now. Creating a square like this is the same as just creating an empty game object and then adding the sprite renderer and then adding this default square. So it doesn't matter which you do. We're just going to replace this with that default sprite. We can go back to our parent object and disable the bean sprite renderer. And now we can also increase the size of our sprite or decrease the size of our collider to make sure these match. In this case, I think I will just increase the sprite. So we could do 2. And now look at that. Our circle collider perfectly aligns. But if your character is a little taller, a little wider, a capsule might be the better option. Anyway, let's rename this square to player sprite. Just going to move it to the top of this hierarchy just for orderliness. And then we can add a animator component on this sprite so that we can get it all animated and hooked up. Like before, we need to make an animation controller. So under our animations folder, right click, create animation, animator controller. So we'll say princess animation controller. And then we will assign that to the controller field. Then we're going to go back to our movement script and then make sure we assign the animator on player sprite to this animator slot so that they're talking to one another. And like before, we have these animation parameters exposed so we can see exactly how the script is going to be talking to the animator. We have 5 of them this time. Is running, input X, input Y, last input X, and last input Y. So they will be a little similar to before, but a top-down player will require slightly more complex animator setup than a side scroller, but trust me, it won't be so bad. First, let's just set up our first animation. Okay, for our first animation, I'm going to go to this grid view, and I'm going to try to pick out, these aren't exactly in order, since they go like on columns in the sprite as opposed to in rows, but I'm going to try and pick out our, maybe our running down animation. So that one looks like the first one, this one looks like the next one, I guess this one is after that, then this one. They're all about 4 units apart, so that looks like a good start. I'm going to drag those onto our player sprite. Go to animations, and we'll say princess run down. Okay, and you'll see that added it to our animator. Let's confirm that that does indeed run. Yeah, there she goes. Pretty fast. We might want to reduce that, but that's fine for now. Let's make a quick idle animation. So it doesn't really look like the sprite sheet has a lot of frames of idle, so I'm just going to use one single frame of animation. Not very animated, I know, but you'll see why this will be fine in a sec. So because we can't just drag one frame into the hierarchy here to create an animation, it actually just creates a game object. It doesn't know that you want to make an animation. We can do this a different way, just so you know another way of setting up animations. So I'm going to click on my object in the hierarchy that has the animator on it. Then I'm going to go to my animation tab. Then we have that princess run down. Here, I'm going to do create new clip, navigate to our animations folder, and we'll say princess idle down. Save that. So that's going to be a blank animation. We have nothing in here. But that is easy to solve. So one way I can get those frames in there is just by docking this animation over here. So now we see both the project window and the animation window. Then I'm going to grab the sprite and just drag it in there. Then we can move it back over. So that's our beautiful one frame animation of the princess just looking down, which will be fine for now. If we wanted to add more animation frames, we could just drag them in here. You could even retime them by moving the keyframes around, but we don't need to do that for now. I just wanted our princess idle down in our animator. I'm going to set that as the default by right-clicking, set as layer default state. Okay, we need to transition from this down to our running state. So this is going to be where it gets a little bit tricky, but follow along and it'll be totally fine. Because we have 4 different animations for running left, right, up, and down, we need a way of managing these 4. So the way we're going to do that is with a blend state. So I'm going to right click, create state from new blend tree. Once we have this blend node, we can double click on it. In here, we see how this thing is managed. The first trick is going to be to select the node and then change from blend type one dimensional to 2D simple directional. Then we're going to need to add in parameters to control the 2 dimensions that we're going to be animating on. So back in our parameters, we need to add those parameters like we did with the knight, and they're going to be the names of our animation parameters here. So first I need is running, of course, to get from idle to running, and then I need input X and input Y, corresponding to like vertical and horizontal input. So I'm going to do plus, and we're going to do bool, as in a true or false for is running. So is running, that needs to be exact caps wise. And as a reminder, you can hover over this if you don't know which type of parameter you need. So this one is a bool. These input X and Y, though, are float parameters, meaning that they're going to be a decimal number. So click the plus, float, input X, and input Y. And when we created that blend tree node, it just automatically made this blend value. You can just right click and delete that. We won't do it. We don't need it. Disregard that warning. Okay, so back into here, we can see that it requires two parameters, that blend one we deleted. So we're going to swap that out for input X and input Y. And now we need to add 4 new motion fields. So 1, 2, 3, and 4 for our running up, running down, running left, and running right animation. This is going to be confusing, but I promise you're going to understand this very quick. So we need to drag in our animation clips into these motion fields. So in this case, I have not created them from the sprite sheet, but at this point you should know how to do that on your own. So I'm just going to grab the ones that already come in the sprite package. So under princess, we can see I've already created ones for idle, down, left, right, and up, and running, down, left, right, up. So for running, we'll do down, up, whoops, click on that again, left, and right. All right, so we need to correspond these to the input. So think of this in like a two-dimensional graph, like in math class. So for running down, down is going to be 0 on the X, as in the middle point, but -1 on the Y, right, to point down. So this little diamond here shows where that is. Right? If we move that around, we can see it adjust these values. I'm just going to Control Z to undo. For up, we want 0 on the X and 1 on the Y. So that'll put a diamond up here. And then for left, -1 on the X is good, 0 on the Y, +1 on the X for right, 0 on the Y. And once we've done that, we should have a diamond in all 4 corners. So what is this? Why did we do this? I will show you. So this red circle represents the input. So this is the directional input, like from a joystick or just, the WASD or arrow keys on your keyboard. So when this upwards motion is inputted, it's going to correspond to, okay, so we have like this input, about 0.3 on the X, 0.9 on the Y. This blend tree is going to know, all right, well, it's mostly pointing up, right? So it's going to choose the Princess Run Up animation. And you can see these highlight as we move around. So like, okay, we're getting more left input. The left is more highlighted. We're getting more down input, right, left. This blend tree is taking our input and then choosing which animation to play for that. And you can see in the little preview down here how that corresponds. Not so bad, right? Hope we got that. Let's actually play to see if that worked at all. Okay, so it looks like we have not actually hooked up our running animation. That's fine. We need to go out of this blend tree, so I could just click on base layer here to return to that. And it looks like I forgot to add our transition from idle to our blend tree. So we can, first let's rename our blend tree to, we'll say run blend. And then let's make that transition from idle to blend. And we don't want exit time. We don't want a transition duration. We do want this is running bool to be true. And similarly, we go back from run to idle down if this condition is false. Get rid of the transition duration, turn off exit time. Okay. Yeah, there we go. So I'm pressing left, we're running left, pressing right, we're running right. I stopped putting input and now we're back to idle. So this is looking perfect. We're not even spinning uncontrollably anymore. We can take this one step farther though, if we actually create an idle animation for all 4 directions too. So in that case, we'd have a blend state for both idle and run. This is totally not necessary. You do not have to do this. I mean, it'd be more work to create more sprites, but if you wanted to be extra super cool, we could have an idle for all 4 directions as well. So I'll just show you how to create that in case you wanted to. It's gonna be very similar. We can delete this princess rundown. We don't need that anymore. But we do need another blend tree. So right click, create state, new blend tree. Gonna call this one idle blend. Double click on it, click it again. We're going to set our blend type to 2D simple directional. This time we're not going to use these input X and input Y, but instead we're going to use the last input X and last input Y parameters. And the reason for that is because we don't want to be using what is currently input when you're idling, right? Because that should be 0. Should be 0x, 0y. Instead, we want the previous one. Make sense? Capiche? Okay. Let's add those. So new float, last input x, can expand that a little bit, and last input y. All right. Back to our blend tree, we're going to change those to last input x, last input y. Set up our 4 motion fields. We'll drag in our idles, so down, left, up, whoops, right, up. And then, so for down, we do 0, -1. For left, we do 1, 0. For right, we do for left we do -1, 0. For right we do 1, 0, and then for up 0, 1, so that our diamonds are positioned correctly. Yep, that looks right. All right, back to our base layer. We now should set this idle blend as the default instead of just this one idle down as the default. So we'll set as default layer state, and then I'm just gonna delete this idle down, and we're gonna recreate those animation transitions. So no duration, no exit time is running true. No duration, no exit time is running false. See if that worked. Perfect, so look at that. We input left and our character is moving to the left, then I stop and we are still looking left. In this case, there's just that one frame of left idle, but it still is pretty cool because we get one of those for each directions, just adding that little bit of polish to our player input. Okay, so with that done, it looks like we have a successful top-down player controller. Many of the future things we will do in Unity will apply to both top-down and side-scrolling type games. They'll each have their own design challenges, but hopefully you can make a pick depending on what kind of game you want to create. I'm just going to save this scene. We'll do File, Save As, and we'll call it Player Top Down. So you can keep these just as references going forward. All right, that's all I have for this video. I'll see you in the next one.